I'm bringing you back to current times again, from the Mayan times. And first of all, let me thank Partha and Peter for inviting me here to talk about Green Revolution and Green Revolution 2.0 and crop biodiversity. So let me first explain what crop biodiversity is, because I'm not talking about overall biodiversity. I'm not even talking about agrobiodiversity. In my paper, I talk more about the extent to which you've got diversity in cropping systems within fields, and talk about land races of staple crops and how those land races have changed over time, and also to talk about genetic diversity within the plant itself. So you can have a plant, you can have two rice plants with different levels of genetic diversity, one having several genes in them and the other having fewer genes in them and coming from various sources. So that genetic diversity is also an important part of diversity. So I'd like to explore all of these in the context of the experience of the Green Revolution, but looking ahead or looking currently at the Green Revolution 2.0 that's going on. And so as I talk through, I'd like to look at different types of changes that are happening. I think one of the things that intensification of agriculture has done, that it's created what we call land sparing benefits. Because you've intensified certain very high potential areas, you've been able to release some of the lower potential areas out of agriculture or out of intensive staple crop production systems. And there have been various estimates around the extent to which the Green Revolution has resulted in land sparing, and some estimates show it at between 18 to 27 million hectares. I'll show you some of the spatial changes that we've observed in India. And then talk about what's the future prospects for land sparing technology change. Then I'd like to go through and talk through land sharing benefits. The land sharing benefits are essentially how, as you intensify the more high potential areas, you release the more marginal lands to having land races, having diversity of crops that are grown, and diversity of different activities that take place. And whether there's a danger now with new technology, especially with biotechnology, that you will start to see monocultures in these more marginal areas, and you begin to see less of that land sharing benefits. A third area is how one can look at in situ conservation of diversity, especially landrace diversity, and whether that in situ conservation can happen through market-based mechanism, market incentives, etc. So these are some of the things I'd like to discuss. But first, let's look at some maps. Look at this two maps of India, one in the late 60s, the left-hand side one, and the right side late 2000s. The late 60s is just at the start of the Green Revolution. And this map plots at a district level rice and wheat production that's taking place across the country. And you'll notice that much of the country is just blue. Some parts are darker blue in terms of higher levels of intensification, and others are less blue. Now, just before I continue, let me explain what I mean by gross cropped area, because I think when people look at Indian statistics, sometimes there's the confusion. Indian crop statistics talk about gross cropped area versus net cropped area. Net cropped area is the actual absolute area that's cultivated, whereas gross cropped area is when you cultivate the same land twice or three times. So if I cultivate a piece of land twice, my gross cropped area is 2 hectares rather than 1 hectare. So when you look at the slide on the right, you find that after the Green Revolution, much of the staple grain productivity became highly concentrated. It became highly concentrated in that northern Indo-Gangetic belt, the belt going from Punjab all the way up to the northern parts of Bengal. That was where much of the Green Revolution in India took place. That's where the rice Green Revolution took place and the wheat Green Revolution took place. In addition to that, you've seen some of the areas around the seaboard, the western seaboard and the eastern seaboard that have had intensive rice production take place. But the really interesting story is to look at the center of the country. Look at the center, going all the way from Delhi down south to Tamil Nadu, just a straight line. And compare that across these 2 time periods. And you find that the center of the country actually started to go out of intensive staple grain production. This is not very well understood by a lot of people. So what happened in India during the Green Revolution was much of the marginal production environments in the country actually got out of intensive staple grain production, and intensive production, staple grain production, went to other parts of the country. And so you were left in the center of the country and the eastern parts of the country with lower productivity staple grain systems, with more of the landrace cultivation systems, land races of rice and wheat and millets and pulses, etc., which became more concentrated in the more marginal central parts of the country. So very interesting change that took place with the Green Revolution. And this was a period when India went from massive food deficits to a country with increasing self-sufficiency and very high levels of self-sufficiency today, although much of that self-sufficiency is around calories. And I'll argue later that there's micronutrient issues that still are bothering the country, and we'll have to address that. So now let's look at what's happening in Sub-Saharan Africa. A few decades ago, Hans Binswanger and I wrote a paper where we looked at population density across Sub-Saharan Africa by standardizing it by land quality. When you standardize population density by land quality, it turns out that a country like Niger has a population density which is similar to Bangladesh, because the area that you can cultivate in Niger is so small that the carrying capacity is very small. Whereas other countries like Tanzania would have a much more favorable population density in this regard. Look at the 2 maps. Look at the one on the left. The one on the left is from around 1980, and the one on the right is by the mid-2000s. So by the mid-2000s, you find that population densities across Africa rose quite dramatically, and the middle part going all the way from the humid tropical area from the West Africa, all the way across to Ethiopia, have seen significant increases in overall population densities adjusted for land quality. So initially in the 80s, we were arguing that one of the reasons Sub-Saharan Africa did not have a green revolution was because the demand for intensification was low compared to Asia. And so intensification and land-saving technologies were not, the demand was very limited for them. But if you look by the mid-2000s, several parts of Sub-Saharan Africa had population densities which were similar to what Asia had in the 60s and 70s. So the demand for intensification became much higher. But at the same time, what happened by the mid-2000s is you began to see improved varieties of crops that are important to Africa. The early Green Revolution was focused on rice and wheat, which were not important crops for Africa at that time. But Since then, there's been improvements in sorghums and millets and cassava, etc., which allowed for African farmers to switch to these new varieties. So you find that over time, Africa began to see improvements in productivity taking place. And some of the recent studies show that if you look across crops, some of the crops that the improved varieties that are now available in Sub-Saharan Africa, there's been significant new adoption taking place. Adoption especially for cassava, for groundnuts, for pearl millets, and also for maize across Sub-Saharan Africa. The picture on the right shows you that some of the big areas of adoption that have happened have been in the most densely populated parts of Sub-Saharan Africa. You begin to see Nigeria, for example, is one of the leading countries in terms of adoption of new varieties that's taking place. And much of the big changes are taking place in countries, the more densely populated countries in West Africa, in Ethiopia, etc. So this change in terms of intensification of agriculture, in terms of adopting more productive varieties, is a real palpable change that you're beginning to see in Sub-Saharan Africa today. And I believe this story is not well told. I believe that people still think of Sub-Saharan Africa as having low productivity, as not being able to innovate, etc. But this change is happening very rapidly, and I anticipate over the next decade you'll see a large change happening, similar to the change that we've seen in Asia in the 60s and 70s. Now, one of the issues that comes up when people talk about the Green Revolution is that there's a concentration on a few varieties. And because there's a concentration on a few varieties, you expose farmers to risks of massive pest infestations, etc. The reality is that in the early parts of the Green Revolution, that was probably true. But over time, you began to see increasing amounts of release of new varieties and increasing adoption of new varieties across Asia. It's certainly true in India, but it's also true in China, in Southeast Asia, etc., where you see multiple modern varieties that are now adopted and used across fields. So spatially, you see a diversity in terms of the varieties that are adopted, although they're all the same crop. So this change has happened more recently, especially in the last 2 decades or so. So then let's ask the question, has the Green Revolution led to a narrowing of crop genetic diversity? And I suspect when you look at some of the data, Melinda Smale has been doing a lot of work in this area, looking at crop genealogies and looking at genetic markers across different varieties, etc. And her work shows that in reality, between 1960s to 2000, the number of distinct land races that have been bred into wheat materials has gone from 20 to 50, and it's gone even further since then. There's a similar story around rice, that a new rice variety that's released today would have 50 or 60 different land races coming into it and providing genes into that plant, whereas the early IR8 varieties were much more limited in genetic diversity. And some of the new wild relatives of rice and the wild relatives of wheat that are now being brought into breeding programs through genomics and other biotechnology advances is actually allowing us to expand that genetic pool further. But then the question that comes up is, what's happening to land races of staple crops? What's happening to farmers who are growing low-yielding varieties of rice or wheat that come through historical transmission, between families and communities, etc. These crops may have particular traits, but in terms of productivity levels, they're quite limited. So what happens to them? You begin to see there's a fairly significant erosion in those varieties. There's a significant erosion in terms of land races in situ and in terms of production of these land races. And I'll come back and tell you why that's happening. So, now we come to this Green Revolution 2.0. I actually discussed this in great detail in my PNAS paper on the Green Revolution. And I've argued in my paper that we're now at the cusp of this Green Revolution 2.0. You start to see it happening in some parts of the world, and it's certainly going to take off over the next decade or so. Now, there's something very different about Green Revolution 2.0 compared to the previous Green Revolution. What's different is that the crops that will be of importance in the second Green Revolution would be quite different from what was important in the first. In the first, it was primarily the 2 or 3 big staples. But as you look ahead, you're going to see that much of the change is going to be on a broader set of commodities. It'll include millets and pulses and horticulture products, etc. And the reason for that is you're beginning to see fairly dramatic diet change happening across the world. And here's some data that from FAO which shows how diets, the number of food groups consumed has been changing over time. And it's not just the numbers that's changing, but also the quantity of food in the different food groups that are changing. So over time, the amount of calories that come from staple grains such as rice and wheat begins to level off and starts to decline, whereas the consumption of calories and protein that comes from non-staples, meat and milk and dairy products and horticulture products, etc., starts to rise. Now, I'm not going to debate on whether the shift to a more meat-based diet is good or bad. All I'm saying is that's happening, and you begin to see the evidence very clearly on that. Now, the interesting thing about that is per capita consumption of staple grains begins to drop as incomes rise and as diet diversity increases. And here's some interesting data from 3 countries looking at Indonesia, India, and Bangladesh, and looking, I lost the time period here, but it was that time period between 1990 and 2010 time period. And what you find when you look at this, both for rural societies as well as urban societies, you find that except for the lowest quintiles of the income distribution, there is a significant drop in per capita consumption of staple grains, both rice and wheat. And the only place where you see an increase is in the lowest quintile for rural populations. And in urban populations, you begin to see that switch taking place much earlier. Now, what does this mean? This means that over time, the relative importance in terms of pushing the overall production of staple grains begins to relax a bit relative to a more diversified diet. Now, I'm not suggesting we move out of staple grain productivity growth. What I'm suggesting is, as you intensify staple grain productivity growth, you're able to release significantly higher amounts of land to go into production of other crops, and therefore to meet the diversity needs, both from crops as well as from livestock products. So that's the change I think you're going to see as you go towards a Green Revolution 2.0. So let me now talk through some of the implications, the biodiversity implications of a Green Revolution 2.0. And I'd like to talk through 5 very specific issues. I'd like to talk about the potential for further land sparing benefits through productivity improvement in high potential areas. And then I'd like to talk about what's happening to the lower potential areas, the areas where the land races have been surviving. How are they going to continue providing a repository of land races? And then about what's happening to underutilized crops, crops that were marginalized during the Green Revolution, crops such as pulses and millets, etc. And the nutritional needs of the poor. We talked about the calorie needs in the first Green Revolution. Now we're talking more about the nutritional needs. And what's the role of biotechnology in either helping or hurting this quest for biodiversity? First, let's look at the productivity side. And here's a really interesting map that was in the PNAS a couple of years ago. And it basically shows that for much of the developing world, and certainly for large parts of Asia and Africa, the current productivity levels are significantly lower than potential productivity levels for the same crop and for similar environments. And so the opportunities for increasing productivity on existing lands, on existing high potential lands, is very, very high. And so as you get to an environment where you're trying to release lands out of staple grains, such as rice and wheat, the opportunity for increasing productivity on current staple grain producing areas will actually help you release large lands out of staple grain production and into other diversity opportunities that there are. So this is something one needs to do a lot more work at a disaggregated level, at a granular level, but the evidence and the data is quite clear from the work that's been done in different locations that the yield gaps are still very high and there's an opportunity to reduce them. Then let's talk about what's happening to the lower potential areas, to the more fragile environments, and what's happening there in terms of technologies. I want to go back to India and show you two maps from the 60s and 2000. Look at the map for the 60s. If you look at the map for the 60s, look at the orange, I think that's orange, the orange area across the whole country. That's basically coarse grains and pulses. This was pre-Green Revolution. And what you find is that because of the Green Revolution, much of the area under coarse grains and pulses was actually pushed away, pushed down from the more high potential Indo-Gangetic plain into the center of the country. So the first thing that happened was coarse grains moved down into the center of the country and into the western parts of the country, to the more fragile parts of the country. So that's the first thing that happened. And if you look at the eastern part of India, the eastern part of India in green was all rice growing area, but much lower productive rice growing area. And this is where many of the rice land races continued to survive. Now what happened by about 1990s is there was a big change. The change happened in terms of significant commercialization of production in the central part of the country. So look at that belt of gray that's cutting through the center and going up to the west towards Gujarat. That gray area is cotton, and it's BT cotton. BT cotton took off dramatically and spread across the country. And today there's about 10 million hectares of BT cotton in the country. And this was the so-called marginal production areas in Maharashtra, in Madhya Pradesh, and in Gujarat, which then took off with BT cotton. Now look at the areas under red. The red areas are under oil seeds. As incomes rose, the demand for oil, cooking oil, etc., rose, animal fats rose, and with that you had soybeans coming in. Soybean coming in, mustard oil coming in, and suddenly much of the marginal producing areas in the center, which were growing coarse grains, switched to more commercial oil producing crops. And India became a big exporter of soybean cake. And one of the reasons it did that was India ended up being one of the few countries that did not have a GM soybean. So India ended up becoming an exporter of non-GM soybean, whereas Brazil and Argentina and many of the other countries were GM soybean exporters. So that then created a whole commercial enterprise and moved the more traditional land races out of the system. Now look at the green area in the eastern part of the country, the lighter green, where traditional land races are growing of rice. What's happened there is now there's some new varieties of rice that are coming in that are tolerant to droughts, that are tolerant to flooding. And these new varieties are now starting to move very rapidly and displace many of the land races that existed there. So you have this new mega varieties of cotton, of soybean, of new rice varieties, etc., that are coming in. And with this growth, there's definitely a change in terms of land races that's happening within the country, and that will continue to be a major issue as you look ahead. Then let's talk a little bit about underutilized crops. One of the things the Green Revolution did was it focused efforts on a few crops. It focused efforts on rice and wheat, and as Paul was saying yesterday, much of that was because the technology for modern rice and wheat were coming from elsewhere, coming from the US, from Japan, etc. But you didn't have technologies around sorghum, you didn't have technologies around millets, etc. And so many of these crops got marginalized in the process. And many of these crops are really important to the poor. You find more recently, of course, that as consumer tastes change, as people talk about organic agriculture, as people talk about more nutrition-sensitive agriculture, markets are bringing some of these crops back up. And quinoa is a very famous example of that, teff. Millets and pulses are another source where more nutritious millets and pulses are now coming into the market. You see iron-rich millets that are now used for making bread in India, etc. So these changes are coming in. And to what extent do markets create an incentive system for maintaining the underutilized species, underutilized crops, is still an open question. Whether it's a good thing or not is still an open question. But the reality is you're beginning to see some of these changes that's coming about. And after several decades of focusing on just the main staples, there is now this new interest in underutilized species that's happening, and that could have very important consequences. What's happening to the nutritional needs of populations? I think one of the things that the Green Revolution did was it really addressed the calorie problem. It addressed the hunger problem through improved supply of calories. Obviously, there's still hunger in the world, there's still hunger in India, but it could have been much, much, much worse if we did not see that productivity growth taking place in the staples. But when you look at some of the data, and here's some data that one of my postdoctoral fellows put together, where she took the entire food that's available in India, looking at food balance sheet data, between 1990 and 2011, and basically calculated the total amount of iron available per capita, the total amount of zinc available per capita, and vitamin A available per capita. It took a lot of time. It took about 6 months to do the calculations and look at the results. And when you look at the results across this 20-year period, one would superficially say that on a per capita basis, there's adequate amount of iron in the country. But the reality is much of the iron is not bioavailable. Much of the iron comes from vegetable sources which are not easily bioavailable. The really bioavailable iron comes from livestock sources and dairy products. And those are still very limited in the country. Zinc, on the other hand, again, has improved significantly. And so you begin to see that maybe on zinc as a micronutrient, we may have achieved some level of sufficiency. But look at vitamin A. Vitamin A, despite all the progress that's taking place, at a per capita level, you're down by about 20% in total availability of vitamin A in the country. And that ought to be a priority. That ought to be the place where we spend a lot of our efforts talking. But you don't see that conversation going on. You don't see that priority for vitamin A. Our president will recognize this man in Time magazine. This is Ingo Potricus. Ingo Potricus was the one who was responsible for developing golden rice, vitamin A enhanced rice. He developed that in 2000. In 2000, BT cotton was also released. Today in India there is about 10 million hectares of BT cotton. There's 0 hectares under golden rice. There's 0 hectares under golden rice in the world today. There's no country that has released golden rice up till today. There are many reasons for that. Civil society pushback is one reason for it. But also, private sector has never shown a big interest in it. Private sector hasn't invested in making golden rice a marketable crop. And so that's also a good reason for it. So you have a situation today where despite the best biotechnology that's available to address vitamin A deficiency, you don't see that adopted and used on farmers' fields. And it's not because farmers are not innovative. Because if you look at BT cotton, certainly farmers have been very innovative. If you look at soybean adoption, farmers have been very innovative. So people are struggling now to say, do we have alternatives that are non-GM alternatives to vitamin A? And the one that's available today is called orange flesh sweet potato. Orange flesh sweet potato was developed through this group called Harvest Plus, which is a group of CGIAR centers that are trying to enrich crops through improving micronutrients, vitamins, etc. So sweet potato is one. There's iron-rich pearl millet. There's iron-rich beans, zinc-efficient rice, etc. There's a whole set of crops out there where vitamin and micronutrient enhancement has been done for the staples and other crops, and done it in a way without GM. The problem is that, again, there's no viable business model for taking these crops to farmers' fields. So unless if you have large-scale public sector intervention, you're not going to see these moving forward. I have one of my students who's just landed in India this week, who's looking at how do you promote orange flesh sweet potato in communities in India, because orange sweet potato is a snack in India. It's not a staple. So how do you take a technology like this and make it more palatable in terms of the diet, etc.? So there's a lot of work that needs to be done around these commodities. But I don't know where the future is. So I think the only way one can think about a more nutritious diet is to go back to basics, go back to promoting vegetables and horticulture products and millets and pulses and livestock products. Because I think the technology fix around micronutrients has been much harder to grapple with than for the calorie side. So then let's come to the last set of issues on, does biotechnology help or hurt in the quest for biodiversity? So I think here it's a good news and a bad news story. I think the potential for shifting the yield frontier and for reducing yield variability is enormous. And biotechnology, both in terms of GM, but also genomics and CRISPR technology, et cetera, can make a big difference in shifting out the yield frontiers and for making the more productive zones bridge some of the yield gap that exists. There's potential for enhancing nutritive value of food crops, but I've told you about some of the constraints around that. And I think using some of the genomic technologies, one can enhance genetic diversity in staples by adding more alleles, more genes into the staple crops and into other food crops. So those are some areas where I think there's potential benefits coming from biotechnology. On the other hand, as you come up with better varieties, as you come up with mega varieties, you find that they could crowd out the land races. They could crowd out the underutilized crops, especially in the more marginal production environments. And also, once you have some mega varieties, you could the intensification spreads into more fragile environments. And these environments may not be able to sustain the intensification pressure. The environmental consequences could be much greater, and that's something we'd need to worry about. But also, I think it's not clear to me that GM food crops have a future. I think BT cotton has had a future, soybean has had a future, canola has had a future. But when you think about food crops, GM rice, for example, hasn't made it very far. The sweet potato hasn't made it very far. There's a GM eggplant, but there's only about 500 hectares under that. There's been a big pushback around GM food crops. And I'm not quite sure where we go from here on that. I'm not quite sure how you change the narrative in order to get these food crops into the mainstream and get them off the shelf. So that's something that many of us think about, but I don't think any of us have a clear path forward on this. So what's the way forward in general? The way forward, I think, as we look ahead, I would argue that in the last green revolution, intensification was tied to a couple of crops. As we look ahead, I've been strongly arguing, and I've written about this in several places, that we need to look at a crop-neutral intensification. What I mean by that is you create all the necessary structures for intensification of production, but you don't promote one crop or the other. Let market signals identify the crops that farmers are growing. But you bring in the roads, the transport, the irrigation systems, the storage systems, the extension systems, etc. If you want to diversify production systems, we need to also look at linking smallholders to urban value chains. The urban value chains is where the growth opportunity is going to be in the future. And if smallholders can benefit from that growth opportunity and diversify their production systems, that can have enormous benefits, both in terms of improving the diversity of the food supply, but also improving smallholder incomes. There's a lot that one can do in terms of science and in terms of information technologies for enhancing nutritive value of foods. And also changing consumer behavior. Using digital technologies for changing consumer behavior around food could be a big opportunity and a big way to promote things like vitamin-rich sweet potato. And one of the frustrations I have as a food policy person is that developing countries, when they think about food security policy, they're basically saying, do we have enough rice and wheat? They're not saying, do we have enough tomatoes? Do we have enough eggs? Do we have enough livestock products. They're basically stuck on the two crops. And unless you get to a paradigm shift of thinking about food as a diverse set of commodities rather than one or two, you run into this problem. And finally, I think there's a lot we need to do in terms of improving the management of in situ conservation, providing incentives, both market-based and non-market-based incentives for conservation of land race diversity. So, thank you very much. I was exactly on time.